Hello, hello, hello. Good morning. How does computer generate big prime number? So we are gonna listen. Let's do this.
Generating big prime numbers, a blend of randomness and rigorous testing. Computers generate large prime numbers, crucial for modern cryptography and other fields, primarily through a combination of random number generation and sophisticated primality testing algorithms. Unlike finding small primes by checking divisibility, generating numbers with hundreds or thousands of digits requires a different approach due to the sheer scale. The most common method 1. Generate a large random number. The process begins by generating a large random integer of the desired size, e.g., 1024 or 2048 bits for cryptographic applications. To increase the chances of finding a prime, the number is often chosen to be odd, as all prime numbers greater than 2 are odd. 2. Perform probabilistic primality tests. Since deterministically proving the primality of a very large number is computationally intensive,
So just to point out, the 2048 bits would be approximately almost 650 digits, digital number, decimal number. So 650 digits. That's pretty huge.
probabilistic primality tests. These algorithms don't guarantee primality with 100% certainty, but can determine if a number is probably prime with an extremely high degree of confidence. A widely used probabilistic test is the Miller-Rebin test. This test checks certain properties that a prime number must satisfy. If a number fails the test for a randomly chosen base, it is definitively composite. However, if it passes, it is considered probably prime. By running the Miller-Rebin test multiple times with different random bases, the probability of a composite number passing all tests can be reduced to a vanishingly small level. For practical purposes in cryptography, the probability of error is made acceptably low by performing a sufficient number of iterations. 3. Iterate if not probably prime. If the generated number fails the primality test, indicating it's composite, the computer typically increments the number by 2 to get the next odd number and tests it again. This process of generating a candidate and testing its primality is repeated until a number passes the probabilistic tests to the required confidence level. While deterministic primality tests like the AKS algorithm exist and can definitively prove primality in polynomial time,
So let's take a look at this deterministic test, AKS, and the probabilistic method, Miller-Irving.